On the top here, we got a parallelogram. We learned some properties about parallelograms. There's some information labeled on the diagram, and then they want to know the distance between S and T, the distance between S and V, TU, and RV. So let's start off with ST. What would you describe ST as? Well, it's definitely not a line. You could say line segment, but more specifically, as it pertains to the parallelogram, what is ST? It's a side because it connects two consecutive vertices. This parallelogram is STUR. If you connect vertices that are in a row that are next to each other, that's called a side. If you connect non-consecutive vertices, what are those called? Need another one of Mr. Romero's patented hints. Yeah. Starts with D and ends with diagonal. Yeah. Dakari, can we take the hoodie off now? Appreciate it. Yeah. So, and we learned properties about each. We learned some stuff about side. We learned some stuff about diagonal. We learned some stuff about angles. So ST is a side. What specifically did we learn about the sides of a parallelogram? Opposite sides are congruent, and opposite sides are parallel. The parallel part of it is more helpful when it comes to finding angles. We're not looking for angles here. We're looking for a side. So if opposite sides are congruent, how long is ST going to be? ST is the same as what the cross went. 46. Yeah, 46 feet. How about SV? SV is half of a diagonal. What did we learn about the diagonals of a parallelogram? We learned one thing about the diagonals of a parallelogram. They bisect each other. They cut each other in half. So SV would be the same as VU, and RV would be the same as VT. They're not all going to be the same as each other, but it gets cut in half. So that this is 46. And then SV is the same as VU, but they don't tell us anywhere here where VU is. But I do see that SU is 39 feet. From S all the way to U is 39. So are there any ideas as to how I could find SV? Divided by 2. SV is going to be 39 divided by 2, which is 19.5. Normally, I like to shy away from decimals, except in the instance when it pertains to measurements. This is the measurement because it has a unit, measuring feet. How about TU? What is TU? No, but like, what is it? TU is it's a side. Opposite sides are congruent. You are correct. TU would be 15 feet. And then how about RV? RV is half of a diagonal. If RT is 67, this would be 67 divided by 2, 33.5. I'm sorry? Because they're two different diagonals. The SV is part of the diagonal SU. RV is part of the diagonal RT. There is no property that said that the diagonals are congruent. Those diagonals are all to themselves, but what they do is they cut each other in half. So whatever RT ends up being, RV is half of that. Whatever SU ends up being, SV is half of that, but they don't all have to be the same as each other. What else would be 19.5? She was asking about 19.5. Not only is SV 19.5, what other segment is 19.5? VU. Cool there. All right, so now let's go to the bottom diagram. Measure of angle T. Okay, so now we're looking for angles. What did we learn about angles of a parallelogram? yesterday, and we went home and reviewed it and studied it. Don't say they are congruent, that's not specific. Which angles? Say it more generally. I gave you notes. Where are your notes? You gave yourself pencils here. Opposite angles congruent. There you go. At least one person's reading straight from the notes. Opposite angles are congruent. And then what else do we learn about angles? Consecutive angles are supplementary. Okay, so they give me one angle here. They give me angle R. Is angle T opposite or consecutive? It is opposite. So what is angle T going to be? What's the measurement of angle T? 48 degrees. Is angle S opposite or consecutive?
It's consecutive.
It is consecutive. So angle S is going to be 180 minus 48. They're supplementary. Okay, 132 sounds good. And then now, since I know that S is 132 when it comes to finding U, yeah, you could do 180 minus 48 again, or since you know that opposite angles are congruent, you could just say 132. All right. Anybody bother to go back and look at the video from yesterday? Sometimes I wonder why I do that. Okay, so this is the one. So I skipped the one that we just did yesterday by mistake. I must have hit the next button twice. But this one we did do, including the one on the bottom. And I was glancing through the notes. That's gonna come back again. So just keep that in mind. Are we all in agreement that we did the two on this page? And it is on the video. All right, so let's keep on going. Let's find CF, find the measure of angle EFC, and then find DF. So let's look for CF. What is CF? Not how long is CF. CF is a side, so we're thinking of our properties with sides. We know that opposite sides are congruent. So ideally, I haven't even read what I'm being given yet. But I really would want them to give me what? If I'm looking for CF, what would I want them to give me? DE would be ideal. I would love for them to give me DE. Those are opposite, and when you look at that, they do give me DE. So what is CF? 74. All right. So let's go now with measure of angle EFC. So EFC is an angle of the parallelogram. The diagonal has no effect on it. It's the full angle of a parallelogram. We just talked about angles. Opposite angles are congruent. Consecutive angles are supplementary. So ideally here, I would love for them to give me EDC. But worst case, if they give me either DCF or DEF, I can use those as well. Let's go looking for angles. The angle they only give me one angle here, and that's FCD. So they're giving me, again, disregarding the diagonals, this whole angle here is 42. So is EFC opposite or consecutive with that one? Yeah, it is consecutive. So if I wanted to be really fancy and write an equation, I would say measure of angle EFC that I'm looking for plus the 42 is equal to 180. Minus 42 on both sides. No? I mean, if you want to just write 180 minus 42, that's fine also. But I'm just showing you how to write it as an equation. At the end of the day, just write it down. Don't rely on mental math. Or actually, fine, rely on mental math, but prove it by writing it down. I can do it mentally too, but if I have to show you, you have to show me. So measure of angle EFC, 138. Now we go to DF. What is DF? Hopefully I don't have to give you a hint this time. That is a diagonal. all we know about the diagonals of a parallelogram, remember they're not congruent with each other, but they do bisect each other. So DG would be exactly half of DF, GF would be exactly half of it. If they give me any information about the other diagonal, that will not help me find the diagonal that I'm looking for. So I'm really hoping they give me something, and they told me that DG is 31. So how can I then find DF?
Multiply times 2.
Times 2, perfect. So DF, when you're looking for a measurement of an angle, you have to write the M in front, that means measure. When you're looking for a measurement of a segment, you just write the 2 points. You don't need to write any other symbols. So DF is 2 times, what was it? 31? 2 times 31, which is 62. Then if you wanted the unit, it's millimeters. 62 millimeters. If it's hard to see, that's why I give you so much space. You can write whatever you want around there. So I would assume it's still better than having to write everything on a blank sheet of paper. Any questions there? Well, because there's 2 of them. Because if it's cut in half, see, if this is 31, this is 31. But let's say you're opposed to multiplication. Out of all the operations, that's the one that you hate the most. Is there another way you could have done this? As long as you know that the diagonals bisect each other, and each of those are 31, is there another way I could have found DF? No. You could have just added 31 plus 31. It's half. If I cut something in half, what's the whole? You can just do times 2 or add it to itself. You look like you're still not sure about it. Okay. Yay, B-ball. There's no Josh here to enjoy. In parallelogram KLMN. So this is going to be almost like, this is like the exact same one that we just finished doing. They just dressed it up as a basketball hoop. It's like if I would have just gone back to this one here and, you know, whatever, and put some type of like a rim around it. That's how I'll be looking. They just dressed this up as a hoop. But here is the parallelogram. You can't see it on your paper. So let's see, find Kn. If you can't see it on your paper, then write it bigger. You got plenty of space to write. Here's K, here's N. That's a side. Opposite sides are congruent. In this case, that's going to be the same as LM. They give me LM. So Kn is going to be just 28 inches. Right, Kn, 28 inches. Find the measure of angle NML. That's an angle of the entire parallelogram, meaning it's like the diagonal has no effect on it. It does not include the diagonal. That's going to be the same as the one that's opposite of it, which is LK. And oh, perfect. They do give me LKN. Sweet. So no work required there. Measure of angle. Measure of angle NML is going to be also 74 degrees. Am I going too fast? And then finally, LO. LO is going to be half of a diagonal. And that diagonal is LN. Do they give me? Oh, they do give me the information here. The entire LN is 26. Oh, nobody say anything. What was your name again? With the light blue shirt. Yesenia. So you told me how to find it. If that entire diagonal LN is 26, how would I find LO? Don't tell her. I see you. Sneaky, 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 Wyatt. Say it again. No, see, because that. Here, I'll make it big for you. Pretend this is the parallelogram here, right? This is L, this is O. Sorry. This is N, and this is O here in the middle. And they're telling, they only want me to find this little piece, and they're telling me that LN The entire diagonal is 26. Divide by 2. So LO is. And the unit is in inches. Any questions there? Ooh, fun. Okay, so find YZ. What is YZ? Is a side. Opposite sides are congruent, so YZ is the same as YX. If I wanted to write an equation here, I would say 8a minus 4 is equal to. No. Or maybe I said it wrong. Sorry. I meant WX is the same as YZ. If I said it wrong, I apologize. In my mind, I was saying it right. Does anybody not know how I got that? Hillary, right? Hillary? You understand how I got? So what do you want to do first then, Hillary? That'll work. Minus 6a on both sides. If you want to combine like terms now, go right ahead. You would get 2a minus 4 equals 10. There's nothing wrong with that. You have my full-fledged support. I just like to combine and do these all at once. So no matter what, your next step is going to be plus 4. So I just do it that way, where all my a's end up on the left, all the constants end up on the right. I get 2a is equal to 14. Divide by 2. And yeah, I'm done. Well, why not? Yeah, because they didn't want A, they wanted YZ. So to find YZ, I substitute like they do in the hood. That's what all the cool kids do. They substitute. When they're not combining like terms, they substitute. There was no unit. Basit, are we okay? All right. And then now measure of angle Z. Okay, so far all we know about measure of angle Z is that it's 9b plus 2. So I need to know B. In order to find B, I need to write an equation. But I need to figure out what to equate. Now I can almost guarantee you that tomorrow on a quiz, just automatically you guys are going to go into autopilot and write up 18b minus 11 is equal to 9b plus 2, just because you see a bunch of b's and you want to make them equal to each other. But you have to think. These are the only two angles that they're giving me. Are those angles opposite or consecutive? Consecutive. Yeah, consecutive angles aren't congruent. They are complementary. So you have to write 9b plus 2 plus 18b minus 11. Instead of making them equal to each other, you have to add them. Let me even, maybe, here, watch. I can add them. I am adding the 9b plus 2 with the 18b minus 11, and that gives me 180. Add equal to 180. Now I gotta solve. Since we're not substituting right now, we're not putting our head down either. The cool kids like to combine like terms. So to get 27b, 2 minus 11 is minus 9. Plus 9 plus 9. You probably need your calculator now. Divide by 27. 7? Yeah, 7 sounds right. And yeah, we're done. Plug it back in. So the measure of angle Z is equal to. Oh, so they ended up both being 7? Yeah. 9 times V plus 2. It's not exactly 7? No, it should be. You might need to return the calculator to them. I got that later. 189 divided by 27. 189. Handwriting that? 180 or 189? Yeah, it's 189. Any other questions? In the back, how are we doing back there? Awesome. Okay, I asked you to remember the problem from yesterday. This is the same one, right? Remember I told you that we did the last one that we did yesterday? This is the one that we did. Yeah. Yeah. So in order to save time today, since we did this here, the difference is yesterday we stopped at just finding W and finding V. Since we have that yesterday and it's documented and it's on the film already, we'll just start with that and then we'll just substitute to find these two. W should have given me 4, and Z would have given me 4.5. You guys have that from yesterday? It was the last one we did yesterday. At the beginning of today's notes, I told you to, hey, remember this? Keep in mind we did this one yesterday. And now let's just use that to find JG. So JG is half of a diagonal. It's W plus 8, so it'll be 4 plus 8. That gives me 12 units. FH is going to be an entire diagonal. So there's more than one way you can do it. Now look, if you want, watch here. Let's see who's clever. Let's see who's clever, right? If you want to plug in the 4.5 into 4z minus 9 and the 2, go for it, add them together. But if you know that diagonals are bisected, look, between these two, which one do you prefer to use to substitute? Do you prefer to substitute? No, that's not a 22, it's a 2z. Do you want to plug into 2z, or do you want to plug into 4z minus 9? Yeah, I would think most of you would prefer to go into 2z. So I would just do 2 times 4.5, but you got to keep in mind, how many of those are there? Yeah, there's 2. So even though the other one looks like 4z minus 9, since they're equal, you don't have to write 4z minus 9. You would just have to multiply it by an extra 2. Since diagonals are bisected, 4z minus 9 is the same as 2z. So I'd rather just get this 2z and multiply it by itself. Or not by itself, sorry, times 2. Add it to itself. It is 18. 2 left. There's 2 left, and then I'll give you back the test. Okay, let's find x and y. First, let's find x. X is part of a diagonal. This half of a diagonal is 2x plus 3. The other one is 5x. Diagonals bisect each other, so I could say 2x plus 3 is equal to 5x. Minus 2x to put all the x's on the same side. So 3 is equal to 3x. Divide by 3. X is 1. If I went too fast, let me know. I'll give you a minute here. Why don't you guys do y? Find y for me. Raise your hand when you got it. You got Y already? What'd you get? Hmm? No. The X's are done. The Y is completely separate. Yeah. Okay. Body coming in strong. Good job. You said 9. Let's see how we got that. That is the midpoint of each individual diagonal. So Hattie, on your paper, you should have 8y minus 36 is equal to 4y. Because that diagonal is also getting cut in half. Each half is equal to each other. I'll just do minus 8y to get all the y's on the same side. So I get negative 36 is equal to negative 4y. Divide by negative 4. All the children rejoice because y is 9. What? One more. Here, you guys do both of these. We've done it a few of these. Find let's ooh, this is a good one actually. Actually, I think about it. Let's do this one together. You won't know how to do this. You won't know how to do this because here you need a system. I didn't see any of these on the quiz for tomorrow, but I'll go back and double check. But we're gonna do this one anyways. But this one you gotta be, because the problem here is when you solve an equation, if you want to get a number, because I want to know exactly what x and y are. There can either only be x's or only be y's. But if you look at all the sides here, they both have x's and y's. I realize the 4 doesn't, but they all have x's and y's. So that's fine. It's not the end of the world. But now if you want to solve for 2 variables, you're going to need 2 equations, also known as a system. Now, luckily, everybody here has taken Algebra 1 before, so if you don't remember exactly how to do it, once I show you, then you'll remember. So, like, if I were to tell you again to take the hoodie off, then you would just remember, even if you've forgotten. Give me 1 equation. So, look, 2 variables, I just need 2 equations. Give me the 2 equations. Okay, 3y plus 2x is equal to 5y minus 2x, cool beans. And then y plus 2x equals 1. Okay, now you would have learned 3 ways to solve these last year. One is graphing, not very precise. It's a good starter because you get to see the solution taking place. What we're looking for is we're looking for an intersection. We're looking to see where this x is the same as this x, and we're looking to see where this y is the same as this y. Okay, so the 2 algebraic methods you learned were substitution and elimination. That was your jam? Yeah, I'm about to. We'll bring them together, but first I want to manipulate them and put them in the form that I want them to be in. Substitution works best if you have a variable that's already by itself. I don't have one by itself, but out of all of these, this y here wouldn't be that hard to get by itself. I would just do minus 2x. In this case, I'd probably recommend elimination. Elimination works best when you have the x and y on the same side. In blue, I already have x and y on the same side. And here, I can just get x and y on the same side by, let's just do, there's no way to avoid a negative. So let's just do minus 5y plus 2x to knock out these two. Then I have to do minus 5y plus 2x over here. So when I bring these together, I have a negative 2y plus 4x is equal to what was left over on the right side? Nothing. Jair, right? That was your first name, Jair? Then as Jair said, yes, normally when we solve these, we write them one underneath the other one. So let me just rewrite this as negative 2y plus 4x equals 0, and then y plus 2x is equal to 4. So I have chosen to go the route of elimination in my estimation. I think this is the one overall kids feel more comfortable with. I don't necessarily agree with that, but you know, for in my experience, they're more successful with elimination. But elimination requires you to have the same coefficient, and then depending on the way you were taught, more than likely a different sign in front of one of the variables. Now, if I look at the y's already have different signs. One is negative and one is positive. So I would recommend going there. But what I don't have is the same number in front, the same coefficient. The top y has a 2, the bottom y, what does that have in front? A 1. So I need to make them the same. Anytime you're going to make them the same, you're going to use multiplication. So I would do that by multiplying by 2. But if you do it, you got to do it to everything. The first equation, I'm going to write exactly the same. Negative 2y plus 4x is equal to 0. The second equation, I will write 2y plus 4x is equal to 8. So now the y's cancel out. And what we're doing, there's more than one way to teach elimination, but I just did it the most common way. When you have the signs different, that's called elimination by addition. So just add. 4 plus 4 is, so I have 8x is equal to 8. So now, after all this, for the first time, how many variables do I have? That was the problem we had at the beginning. We had 2 variables, but now at least we only have 1. So I get that x is 1. Now that I know that x is 1, I can get that 1 and plug it anywhere I want. I'm guessing you're going to want the one in blue over there. But you can pick any equation you want and say y plus 2 times 1 is equal to 4. That was the equation that was up here in blue. So I get y plus 2 is equal to 4. Minus 2 minus 2. How far up? Can I go like this? So this asks me for, it didn't ask me for the side, but this asks for x and y.
Yeah.
So there's x. As she's writing that down, are there any questions there? I didn't see any of those on the quiz tomorrow. It was a system. I don't think you should have to solve a system, but doesn't mean you should know how to do it. So as of right now, if I were to just give you the quiz and like hand it out now, all of you should be ready to go. Luckily, you won't have the quiz right now, but that's what's going to be on it. I will turn.